Hi everybody, today we're going to talk about the natural base E in terms of exponential growth or decay. So the natural base E symbol is E, the natural base has a symbol of E. It's an irrational number and is approximately 2.72. We can find this on our calculator and we will do that in class tomorrow. The graph for the natural base is the same shape as the exponential growth graphs because the base is greater than 1. 2.72 is more than 1, so it'll be a growth rather than a decay. It has the same go-to point at 0, 1, and the same asymptote at y equals 0. If we are simplifying natural base expressions, it follows the same exponent rules that we learned last semester. Remember, when we multiply, we add exponents. When we divide, we subtract exponents. And exponents with an exponent next to each other, then we multiply. Negative exponents still take things and flip their base. Never make a negative answer. And if we're adding same bases with same exponents, the exponents we do not change. So in example 1, we have e to the third times e to the sixth. So when we're multiplying, we add exponents. So that's e to the 3 plus 6 power, which is e to the 9th. Remember, we're simplifying, not evaluating. So I don't want to know what that is. I'm just trying to take it and make it smaller. For example 2, we're going to take these into like bases. So 16 and 4 are coefficients. I'm allowed to go ahead and reduce those if I can. 16 divided by 4 is 4. E to the 5th over e to the 4th. This is division, so we subtract exponents. So that's e to the 5 minus 4 power, which is e to the 1st. So we can write it as 4e or 4e to the 1st. Doesn't matter, it's your preference. And example 3 is the exponent with an exponent power rule, which means that not only does this square go to both the 3 and the base e, but we'll be multiplying that negative 4x by 2. So we have 3 squared, and then negative 4x times 2 is negative 8x. Remember, we are not allowed to leave negative exponents, and the negative exponents only applies to the e, not the 3. So I'm going to go ahead and say, what is 3 squared? Well, 3 squared is 9, and then e to the 8x is now underneath in the denominator. I'm going to go ahead and give you these points, and then tomorrow we're going to talk about how to find these in the calculator with E, because we have to locate E first. Still going to take at least 3 points on an XY table. This is still something where our asymptote will be 0. Our go-to point may or may not be 1, depending on A. Remember, this is a stretch or a shrink. Stretch or a shrink, depending on what value A has. I'm going to pick negative 1, 0, and 1. And so we have 3e to the negative first power, which is 1.1. 3e to the 0. E to the 0 is 1. 1 times 3 is 1. And then 3e to the first is 8.2. So I'm going to have negative 1, 1, see, that's 5, 6, 7, 8, and 9. So this is here roughly 0, 3, and then 8.2. So you can see it's still an exponential growth with an asymptote at y equals 0. Number 2, again, still want to have our xy table. Plugging that in, e to the negative 0.5 times negative 1 is giving us 2.7. E to the negative 0.5 times 0, well, negative 0.5 times 0 is 0, so e to the 0, anything to the 0 is 1. And then e to the negative 0.5 times positive 1 is e to the negative 0.5. Sorry, I'll switch these to 2's. 0.37. When I plot this graph, negative 2, 2, 4, negative 2, 2.7 is about here. There's our 0, 1, and our 0.37. This one is a decay. And that's because of this negative 0.5 right here. When that value is negative and the exponent, it'll change it to a decay problem. And we'll talk more about that tomorrow in class. Continuously compounded interest. So today in class we talked about compounding interest and the different uses for it and the different examples. So what happens if something is compounded continuously? That means it's like I hit the enter button or the equal button on my calculator as fast as I can, as many times as I can in a minute. I wouldn't even begin to describe how big of a number that could potentially be. So because of that, they came up with the PERT formula. We'll talk about the ad, the commercial for PERT, when we get to class tomorrow. But PE to the RT power. P is still the principal, R is still the interest in decimal form, and T is the amount of time we are compounding it for. E is that letter E in your calculator. So again, we'll go through how to find that in our calculator in class tomorrow, and we'll do the last 2 examples using this PERT formula in class tomorrow. Have a great night.